Welcome to online classes. Now we discuss the chapter second of force and law of motion. In the previous lecture we have discussed the various laws which is related to Newton's, and first we have to discuss Newton's first law. After that we have discussed Newton's second law. After that we have discussed the Newton's third law also. That is called action reaction pair forces. Now we have to go on the basic concepts of conservation of momentum. So we have to introduce the concept of conservation of momentum. So we have to see that what is the basic concept of the momentum is here. What is the basic formula of the momentum is P is equal to N into V. This is the basic formula for the momentum. We have to introduce in the previous lecture what is the basic formula for the momentum, mass and velocity. That is the product of mass and velocities. The conservation of momentum is applied only when the system is applied any external force on the system. Suppose we have to see here. This block is kept here, and this block having mass of n kg, and here we see the weight is acting vertically downward direction, and it is always acting at a point of center of gravity that is called CG. W is equal to mg. If this weight is compressed the ground, because this block is kept on the ground, so we have to see that this block is compressed the ground. If this compressed the ground, a reaction is force is acting by the ground on the block in the form of normal reaction. This is the normal reaction, that is the force acting by the ground on the block, and this is the force acting by the block on the ground. And these forces is called action-reaction pair forces. If we see that the net external force is acting on the object will be 0, because N is equal to mg, and this is equal to W. Because N is acting vertically upward, that is to be normal reaction, and this force is to be balanced by the weight of mg. Because in the vertical direction the block is not moving anywhere, then we can say that in vertical direction both of the forces should be balanced here. So we can see that N is equal to mg. And here we know that if any system, that is net external forces acting on the system will be 0, then the momentum of the system will be conserved. What is it means? We simply say that if a particle is, if symbol, this is a block, and this block having a mass m kg, a bullet is coming from here. That is a small m kg bullet is coming in this direction with a speed of v, and this block is in rest condition, that is capital M. So here we see that when this bullet is strike to the mass of capital M, this is embedded here like that. This is embedded inside the block, and here we see that after a time interval delta t, this block is moving, and this bullet is get inside and embedded here, and this block is moving, capital M block plus small m bullet is moving in this direction with a velocity of v1. This is the before collision status, this is the at the instant of collision status, and this is after the collisions. The both of the systems will be embedded together and moving with a common velocity, that is 2v. And here we see that all the states, we have to see that when the bullet is striking to the mass of m, If force is acting on this block in this direction, that is called F impact. And because of the action-reaction pair forces, the block gives another reaction pair forces on the bullet. That means in its directions. Both of the forces will be cancelled out here. And hence we can say that the external force on the system will be zero. And hence we can say that momentum of system will be conserved. So first we have to recognize that where momentum of the system is being conserved or where the system momentum is not being conserved. So first we have to see that the next external force, the condition is that F net on the system is zero. The net force which is acting on the system is always zero. When it is in moving condition or it is in rest condition, then momentum will be conserved. Momentum will be conserved. So here we can see that this is the external force that is to be acting by the bullet on the block, and because of the Newton's action-reaction pair forces, the block is applied the forces in opposite magnitude. Both of the forces should be cancelled out here. So here we can say that the momentum of the system will be conserved here. So here we see that the net momentum of the block will be conserved. So we can write here, if the momentum of system will be conserved, so we can say that initial momentum is equal to final momentum. So here we see that initial momentum is equal to final momentum. What is the initial momentum? We have to write the initial momentum of both the systems. So first we write the momentum of block. M into B is the basic formula. When the block is in rest condition and having the mass. Rest condition means velocity is 0. So initial momentum of the block is M into 0 plus. What is the momentum? Initial momentum of this bullet. And this is to be minus because this is in rest condition, and suppose this is the positive direction and this bullet is moving in opposite direction. Hence minus small m. This is the initial momentum. This is the total initial momentum. What is the final momentum? So we have to see the after steady state condition of the positions. So we have to see that small m plus capital M. This is the total mass. What is the velocity? That is the total velocity. So we have to find the final velocity of the system. That is the basic concept. So we have to learn here. So conservation of momentum is only applied when the net external force on the system will be 0. The momentum of the system will be always conserved in this manner. So we have to apply. There are various types of examples here. A bullet is passing through the barrels. The system momentum should be always conserved because the bullet, suppose we have to see that this is the barrel of the gun and bullet is moving in this direction. If bullet is moving in such direction, then it gives a reaction forces because of the Newton's action-reaction pair. When the bullet is just outside, when from the barrel, then this bullet is going in this direction and this gives a reaction forces in this direction of the same magnitude, because Newton's simple law says that action-reaction pairs are equal in magnitude but in opposite direction. Hence both of the forces should be cancelled out and net force of the system will be 0 and momentum of the system will be conserved in this case also.